Before we get rolling, I just wanted to point out that I'm going to provide an overview of a big area, and so I'm not going to go through individual studies sequentially. There are individual studies, but I will tweet these studies. I'll tweet you the links to the full text of the studies later, but I'm not going to go over the individual studies as we go, just to say that they're there. I also want to say that this is much of the work that I was involved in that I'm going to be talking about today I did with this fantastic group of collaborators, and I want to be sure that that is clear from the outset. So, okay, let's get started. I have never been to Penn State before. It's great to be here, liking it so far. I wanted to figure out something about it, and so I thought maybe Google autocomplete could help me. So I typed in, will Penn State, and I got these answers from autocomplete. I'm not familiar with Penn State. I mean, that familiar, so I don't know. You'll have to, will basketball ever be good? I know. Then I tried do. I got these for do Penn State. I'm thinking that the dorms have bathrooms. But all this to say, one of the experiences that perhaps you've had when using Google Autocomplete is a central topic of my talk today. And that experience I can perhaps best give you by this autocomplete, which is no longer working, unfortunately, but it's how to raise your, produced at one time, the autocomplete, how to raise your IQ by eating gifted children. Now, this is an uncanny experience with computing, where something happens and you might find yourself asking, why did this happen? What a strange thing that this happened. And you wonder a little bit about Google. Like, what is it that produced this particular result? Or you wonder a little bit about Google users. That's my topic today. It's our relationship with personalization algorithms that curate information, media, news, and pretty much everything else. On a more serious note, it's a timely topic because these algorithms are extremely pervasive, and the problems with them have also been extremely pervasive lately. This is from a recent blog post by a Facebook user who was surprised to find that Facebook suggested that he should join Alcoholics Anonymous. And he found himself, again, wondering why exactly this suggestion was made. He photoshopped this to edit the faces of the people because they were not blurred in the recommendation. Another more serious example that some of you may have heard of, which was documented by Nick Mursoff, is recently, because of the Syrian refugee crisis, a number of people, including artists and journalists, tried to popularize the plight of Syrian refugees. And one of the ways they tried to do that is Facebook. Of course, now many people get their news and information from Facebook, so that's a legitimate strategy that makes a lot of sense. However, Mursoff found that whenever he tried to talk about a particular art project called Multicultural Graveyard, or tried to show or link to news photography about Syrian refugees drowning, that they would disappear from Facebook. And he was very puzzled by this behavior. He wrote about it extensively and ended up concluding that it had something to do with the fact that people found images of drownings uncomfortable, and they would always report the image, and then it would be censored. So he found himself unable to have a conversation on Facebook about a humanitarian crisis. In a similar vein, a year before that, Zeynep Tufekci wrote in Medium about her experience on news about Ferguson. So Ferguson was a raging topic, but only on some networks and not other networks. So she commented that on Twitter, the word Ferguson was trending. Ferguson and stories about Ferguson were all over her Twitter feed. But then when she switched to Facebook, she saw nothing. And she attributed this to the algorithm, although, of course, she doesn't know, and neither do we. We're not sure exactly why that would happen. My point to you is that this is really an unprecedented moment when we're curating our news and information through these systems. And the news reports that have filtered out about how these systems perform do not give you a lot of confidence. You could say that there's now an algorithmic backlash to go along with the algorithmic popularity. The Wall Street Journal wrote this story about Google's image tagging algorithm. It tagged black people as gorillas. Similar things have happened with all kinds of image tagging algorithms. Maybe you heard the Flickr was, I believe it tagged Auschwitz with sports and other things like this. This has led to a campaign against algorithms that curate information. The recent announcement that Instagram was going to switch to algorithmically curated feeds produced these Instagram images where people would protest the use of the algorithm. They didn't want the algorithm, and they would sing the praises of our old friend reverse chronological order. Twitter's for about 2 years now, Twitter has been claiming they're going to switch to algorithmic curation. They actually did for the most part, but then they've kind of been keeping it secret because every time they announce it, they get this huge backlash of people angry about algorithmic curation. I believe if I were to interpret this tweet correctly, it would be saying that if Twitter switches to an algorithmically curated timeline, that will be the experience like opening the Ark of the Covenant in the original Indiana Jones movie, and my face will melt off. So strong feelings, I think, is what this is trying to convey. Maybe in the same vein, I think this person is saying that it's such a big deal that he would actually vote for Donald Trump if Donald Trump could stop Twitter from implementing a curation algorithm. Here's some text that you can find on Facebook. It's under a little down arrow, and it comes next to something that's been algorithmically selected for you. You find text like this on all kinds of interfaces. Google search results used to have a little I. Sometimes there's a little question mark. They say things like, why am I seeing this? And then when you click on it, usually there's a spectacularly uninformative text box that says something like, we're showing this to you based on your past behavior. Or something like, this is something that our advertisers thought you would like. This is, I think, something a little more profound. You could say that this phrase, why am I seeing this, it's also the experience of the autocorrect or the autocomplete that I started my talk with. It's the experience of interacting with algorithms when they produce something unexpected. Why am I seeing this? Look at it a different way. This is what we're all here for. And I mean, all of us who study the media industries, media, communication, journalism, why am I seeing this? That's the mandate for the study of the media at all. Why am I seeing this as our central problematic? It's why we're here. Yes, it was framed in different terms in the past. We would ask things like, well, how does the editor decide what is news in the newsroom? But why am I seeing this is the fundamental question. It rises to the point of a call to action, a philosophy, a crusade, an underpinning for everything that we're doing. Why am I seeing this? Algorithms are changing the terms of this question, why am I seeing this, and the operation of its answer, the production of its answer. In the next part of my talk, I'm going to narrow down exactly what I'm talking about when I say algorithms and give a little more explanation. So far, I've just been saying that, but I haven't explained what I'm talking about. It is kind of a mystifying area. I mean, we have to admit that. This is genuinely an actual ad campaign that really existed in the San Francisco Bay Area. I'm not saying it was a successful ad campaign, right? But someone did pay for this ad campaign. It was trying to be a viral ad campaign. It was originally unsigned, so it just said the sentence and nothing else. I guess we can tell it didn't work, right? Because how many people search the web using ask? Yeah, right. But anyway, there's a sense that the algorithm is some sort of mystical or complicated thing, and it's owned by the computer scientists, and it's got a lot of letters in it, and no one's really sure exactly what it means. Another ad in this campaign was, the Unabomber hates the algorithm, right? Because supposedly he was found through search results, right? But that's several steps of reasoning down the line for most people to get. The excitement about algorithmic curation is also pervasive in academia, in the study of these systems, in people who study the media and information. David Laser is a good example. He's really well known as a quantitative researcher focusing on big data, and he recently went so far as to call for a new field around the study of the social algorithm. I mean, that's a big deal, a new field. Similarly, David Goldberg, a really prominent digital humanist, so a very different methodological perspective from the last quote. And Goldberg and Ng say, algorithm studies is the new field, so they've coined the new field, here we are, and it's the study of the algorithm. Tarleton Gillespie, he says, that we're turning to algorithms to identify what we need to know is as momentous as having relied on the Word of God. So again, we've got a lot of excitement about the area of research I'm talking to you about today. But what exactly is it? What exactly are we talking about? And I'm here to provide, I hope, some relief to the hype about it, because the definition that we're using is actually a very simple definition. An algorithm, in the definition we're using, is just a procedure or a set of rules that are used to accomplish something. And that's actually a definition that's very old. So algorithm is a very old word. Ted Strepis wrote some really interesting things about the history of the word. Algorithm actually appears in Canterbury Tales by Chaucer, right? So it's a really old word that was taken by computing and made technical fairly recently. But the basic idea, most of the time that it's used, is just a procedure or set of rules. So when they teach Introduction to Algorithms in computer science, they sometimes use as a synonym the word recipe. So when we're talking about an algorithm, we're talking about a recipe, a series of steps used in problem solving. One of the examples that is sometimes used in Introduction to Algorithms in computer science is the directions on a shampoo bottle. Maybe you didn't know that shampoo bottles had directions, but they do. This shampoo bottle says to use wet hair, lather, rinse, repeat. Right? So a couple of things to note about this. All right, so it's useful to think of as an algorithm. It's a series of steps. It's a procedure. It's instructions. Also, there's different ways that you could do this, right? My college roommate in the dorms when I first went to college did not use this procedure at all. He used a very different procedure. I don't know what it was. It didn't produce much cleanliness. I will tell you, I had a real problem with him. But there's a lot of different ways we could write the procedure, right? I mean, so in fact, computer programmers would say this is a pretty crappy algorithm, right? Because it's infinite, right? I mean, that's a bad idea. You're just washing it and you're washing it. That's computer science humor right there. That's about as funny as it gets. So enjoy that laugh. Another way we could think of this, though, is we know that the algorithm is optimizing for something, and there's different ways that it could optimize. In this case, you cynical people in the audience might think that this is optimizing for using shampoo or something like that. Like, I don't actually repeat, right? I just use the ones. I'm not going to ask a show of hands or anything like that. I've said more than enough about shampooing. But my point is that you could write one of these and it could optimize for water conservation. You could write one of these and you could optimize for using the most shampoo. You could write one of these and you could optimize for speed, right? So there's different ways that we could write an algorithm. All right. Why did computing steal this word and make it technical? Don Knuth, a very famous computer scientist, tried to answer this question in the 1960s. He says, the word algorithm denotes an abstract method for computing some function, while a program is an embodiment in some programming language. Okay, let's get into what he's talking about here. So Knuth is saying we already have this word computer program, and that word is working out well. No need to change that word. We know what a computer program is. But the problem is that we usually write a computer program so that it'll work in a particular computer language or with a particular computer. We need a word that is more general or abstract, and that's algorithm for us. Because we don't want to always be talking about program. Sometimes we want to talk about the strategy behind the program. So when we say, what's the algorithm, we're not saying, what's the program, or what instructions did you give the computer. We're saying, what's the strategy? What exactly were you trying to accomplish, and how did you do it? How did you write the procedure? You could, going back to the recipe metaphor, you could say that a recipe is a little bit like an algorithm, and how you actually cook the food in your kitchen is a little bit more like a program, right? Because everyone's kitchen is different. In the end, they don't all work out the same way. So the algorithm is the strategy. So the current excitement about the idea of algorithms and figuring out algorithms and what's happening with algorithms is really about figuring out the strategy, or what exactly is going on. Why did it come out this way? What did you put in there? Among the different ways you could have written the instructions on that shampoo bottle, why did it come out this way? It's weird. If I come right here, I get a little bit of a feedback echo. Should I turn this off or something? Like, this is the only other mic, right? I think, did it go away? I think it went away. That seems better. All right, good. Well, it's okay for you, but it was making me a little, yeah. All right. Okay. So in media communication and information, algorithms that filter and curate are everywhere. I mean, they're really everywhere. So we had, like Nissenbaum and Trona a while back wrote a famous article about how Google search is political, and the results that Google gives you are actually not technical. You should think of them as economic and political and cultural and social. But that was a while ago, and when they used the word algorithm, it was just about search engines, and we just thought of algorithms as being about search engines. I just want to emphasize the degree to which these algorithms are now everywhere, and that this has happened in a very short amount of time. So in my earlier examples, I referenced the Facebook newsfeed algorithm, right, which decides what you see when you log into Facebook. Facebook didn't have a newsfeed when they launched. And when they launched the newsfeed, it didn't have a filtering algorithm. It was reverse chronological order. So Facebook actually only added the newsfeed fairly recently and only added the algorithm within the last few years. Similarly, Gmail. Good old reverse chronological order. That used to be the way we looked at email, right? But 2 years ago, very recently, Gmail changed its system so that it tries to identify what messages are important. It calls it the tabbed inbox or importance flags. It's true it was already filtering if you count spam filtering, but the filtering became much more common. So we now have an algorithmic mailbox. Similarly, I said earlier, Twitter, Instagram are filtered using an algorithm. But even things like the Steam discovery queue for any of you gamers. I mean, we're seeing in like all kinds of different areas the idea that there's a big corpus of some information. There should be an algorithm to decide what in that corpus you get to see right now. You could say that the most pervasive example of algorithms in media communication and information are probably an ad selection. That probably is what you see the most of, right? Because every time you see ads along the side of your screen or a banner ad at the top, there's a big corpus of ads, and some algorithm has decided that you should see those ads right now. So this stuff is really everywhere, and it's happened only within the last few years. Now that I've kind of drawn a circle around what I want to talk about and given you a few examples of that, I'd now like to go to sort of the meaty part, although, again, I'm sorry it doesn't have any cat pictures. I really would have put them in if I thought that's where this was going to go. I'm going to talk about 3 ways to think about algorithms, and I'm going to put those up on slides later, but basically the 3 ways are co-production, I want to get them in the right order, co-production, algorithmic determinism, and corrupt personalization. But I'm going to explain what I mean by that, I'm going to explain. Here we go. Here we go. So co-production, the first of 3 ways to think about algorithms. So co-production is a term from science and technology studies, most closely associated with a scholar named Sheila Jasanoff. And basically, the term is actually used by Jasanoff in a very complicated way to give you a kind of hackneyed version of the way that she uses the term. She tries to say that technology and society are co-produced as a way of getting out of the debate where you say, oh, well, this thing is social and this thing is technological. So co-production is her way of getting out of that story about like, oh, here's a new technology and it has consequences, or here's social practices and they respond to technology. She's trying to mix them together, and she has this idea, she has this term, co-production, to help us see that. I'm going to use that term to build a little more specific way of thinking about algorithms by going through a few examples. And I'll start by talking about this again. So how to raise your IQ by eating gifted children. Now, sometimes when we're looking at an algorithm that selects something for you, you might have an experience that's uncanny or bizarre, but it is actually not a strange experience. In fact, some algorithms are very simple and produce weird results. So it turns out there's a book. The book is called How to Raise Your IQ by Eating Gifted Children. It's a humor book. And so in this case, the algorithm is probably whatever people are searching for a lot right now, put that at the top of the list. And maybe there was an author event, a book signing or something, right when this was typed in. I don't know, right? But you could imagine, again, though I don't know what the algorithm is, but you could imagine that a very simple algorithm could have produced results like this one. And so even though it might be uncanny, it's not actually that strange or simple, right? But then there's actually algorithms that you might say are a little more complicated, and it's not clear how to think about them, right? So this is a news story about Donald Trump. The news story, Social Flow is a social media consulting group, and they announced that after their analysis of Twitter data, they found that an unbelievable amount of dominance of Donald Trump on Twitter, and they talked about some reasons why. But let's think about this a little bit. So if I wanted to understand why something was popular on some system that had algorithmic curation, like Facebook or increasingly Twitter, if I wanted to figure this out, there's a couple of ways that I could think about it, right? Especially if I wanted to think about who actually did something or who's responsible for something, because we're talking about co-production here. So if I were to write an algorithm right now, real time, with all of you watching me, if I were to write one, and that algorithm would produce Donald Trump's unprecedented rise, I could write an algorithm like the last slide. I could say anything that has the word Trump in it should go at the top. Like that would be an algorithm I could use. And that would be very simple, and it would produce this situation, and it would be very simple and easy to understand. Though it would still be secret, because the companies involved wouldn't want to tell you their algorithm. So I could write that algorithm. I'm not saying that actually happened. I don't think that it did. Absolutely not. But that's a very simple algorithm that I could use. Now, if I asked you who's responsible for Donald Trump's rise, who's responsible for Donald Trump's rise in the media in that case, if that is the algorithm, it seems like it's me, right? I mean, I wrote Donald Trump. If it has Donald Trump in it, then put it at the top. So it seems like it's me. I'm like an editor, right? I did something there by writing that algorithm. Okay, but what if we wrote the algorithm a different way? Here goes another way to shampoo your hair. I mean, another algorithm. I'm going to do another algorithm. So what if we said something else? What if we said, we're going to make a system, and everyone in this room is going to vote on what they like. Maybe there's a like button. And you're all going to press the like button if you like something. And then whatever has the most likes should go at the top. So that's an algorithm I could use to determine what goes at the top. All right? Understand the algorithm? It's pretty simple. What if I asked you who's responsible for Donald Trump's dominance in the media in that case? Well, it seems like it's you, right? Because you voted and it went to the top. Like, yes, all right, maybe there's some ways I could have rigged the voting a little bit or done the voting one way versus another way, but more or less it seems like it's you, if that's the algorithm and Donald Trump's at the top. It seems like it's you. But then, when we think about the way that social media algorithms and content curation algorithms actually work in systems right now, they don't really work like either of those things. Instead, they work a little bit like this. You would write the algorithm and you would say, well, what I'd like is instead of just writing what I want the media system to do, what I'll do is I'll write a way for it to program itself. I'll say, dear media system, I'm going to give you somewhere between 150 and 1,000 factors. I want you to use some fancy statistics and look through those factors and decide what optimizes for a particular outcome that I like. Maybe the outcome is time spent with my media platform, time spent on screen, eyeballs. Maybe it's ad clicks. Maybe it's likes. Maybe it's comments. Maybe it's interaction. It could be any of those things. Maybe it's revenue, so you want to account for the fact that some ads pay you more than others. But I'm optimizing for something. So I'm going to write this algorithm. I'm going to say, all right, I want you to put 150 to 1,000 factors in a statistical function, and then I want you to make a decision about what goes on the top on the basis of that. Now, in that scenario, you get to control some of those factors because you're doing things. One of them might be, did you click like? One of them might be, did you scroll down? Right? But I'm controlling some of the factors too. So I could have weightings. I could say, well, let's weight politics a little higher or a little lower, right? So I control some of the factors. You control some of the factors. Now if I ask you who's responsible if Donald Trump is at the top of the media system, what do you say? I mean, it's hard to know what you say in that point. And this is Sheila Jasanoff's point with co-production, because you did some things, I did some things. Together, we co-produced some Donald Trump. He was at the top of our imaginary media system. But who exactly is responsible? Well, it's complicated. In fact, in this scenario, if I asked you how we did it or what exactly were the steps that went through that produced the Donald Trump, it might be a question that is effectively unanswerable, as I'll talk about a little more later. All right. So let's continue with co-production by going through a few examples. So if we say that something is co-produced, that it's not you and it's not the machine and it's both together, there are some interesting implications of saying that. So we're not just saying, oh, I'm making an abstract theoretical point. What I'm saying is actually that because these things are co-produced, there are a variety of sometimes pleasantly surprising, sometimes shocking, sometimes bizarre implications that come out of that co-production. Let's take Facebook as an example. I don't know if anyone posts baby pictures on Facebook. Has anyone posted them on Facebook? It's a very common use of the platform. I know some of you may have a baby in a few years. I don't know, just making generalizations about the age of the audience. But when you do, it may be common, if Facebook still exists and is trendy enough, for you to post baby pictures on Facebook. So here's Mark, the Zuck. He's got his baby picture on Facebook. Most popular comment, put a blanket down. I don't know if that's germs or I'm not sure what that's about. Anyway, so interestingly, there is a significant subset of the population that hates baby pictures on Facebook. So I didn't know this, but I guess maybe if you don't have kids or maybe you hate them, I don't know, but you see baby pictures on Facebook and you don't like them. There's actually a software platform that was launched called UnBabyMe that goes through and removes baby pictures from your Facebook newsfeed. And actually, one of the things it does, if you want, I'm going to get the cats in, if you want, you can replace it with pictures of kittens. So that's almost a lol cat in there, right? So, the people who came up with UnBabyMe, one of the things that they talked about was the fact that when parents have babies on Facebook, they become insufferable. I guess they weren't parents before that, but they post all this stuff about their babies, and these people don't like it, and so they make this UnBabyMe. What does the research say? So there's an interesting study that I had nothing to do with, but a great study by Meredith Morris, Microsoft, that is about how mothers of young children use Facebook. Interestingly, mothers of young children, after you have a baby, it turns out you're pretty busy. So mothers of young children do not post more pictures on Facebook. They post dramatically less, dramatically fewer pictures on Facebook. And you could argue that compared to their behavior before having a baby, they are dramatically underrepresenting this part of their lives. They post extremely few pictures of babies compared to what you might expect, according to Dr. Morris. So what's happening? What's going on? Well, one explanation, again advanced by Dr. Morris and not me, is the algorithm. So one explanation is the algorithm. It's that if there is a baby picture on Facebook, maybe Facebook is showing it to people. And so it creates the false impression that mothers post a lot of baby pictures, even though, in fact, we find that they don't. So you see a lot of them. But why would the algorithm produce this behavior? I mean, it seems, I don't know, like you could say a lot of things about Zuck and Menlo Park, but it seems like a pretty minor thing for them to be optimizing for, right? I mean, I don't know, babies. But, one way you could explain it is with the idea of co-production. You could say, well, look, what we have here is that there's a variety of social norms about babies, right? You know the old jokes, maybe you don't, the old jokes about how you're not supposed to ever say anything bad about a baby ever, right? So if someone shows you their baby, you never say, oh, that's an ugly one, or anything like that, right? There's a lot of social norms about babies. So it could be that when you're shown the picture of someone's new baby, you basically have to like it, right? You have to like it. Right? You don't have any choice. But then that's what the algorithm is looking for, right? You're training the algorithm and it's training you. So you get this interesting feedback where new babies produce likes, likes tell the algorithm, and then mothers have babies, you get babies all over Facebook. And so you get this cycle of babies, and it has to do with this idea of co-production, the technical and the social, the norms and the technology. Another example that's of the same phenomenon that's a slightly more serious is a study done by Professor LaTanya Sweeney at Harvard. I don't know if any of you have remember this, but I bet sometimes the people in this room Google their own name. I bet that happens sometimes. And when you Google your own name, you get these ads, at least you used to, you don't get them anymore. You get these ads when it would say public record search, background check, find out the real name and address of, these kinds of ads. So I don't know if anyone remembers seeing these, but you used to see these when you would Google your own name. Intellus, I guess, was a big advertiser in those kind of searches. So Professor LaTanya Sweeney, I guess she Googled her own name or something. She Googled someone's name, and she was surprised to find that some of the ads said the name she searched for, comma, arrested, suggesting that, that person had been arrested. And, and she thought, that's kind of funny. I haven't seen that arrested one before. And then, just out of her everyday searching, maybe Googling for job applicants or whatever name she's Googling for, she thought, it seems to me as if I Google the name of a black person, that I am much more likely to see this comma arrested ad come up. And she's a computer scientist and a professor of government, and so she thought, this bears some looking into, right? What's the story with this, right? So she performed a study, which is called Discrimination in Online Ad Delivery, and found that, in fact, she used the names in the U.S. Census and then Googled all of them and looked at the ads that were returned as a result. And in fact, she found that ads suggestive of arrest records were significantly more likely if the name that was searched for was African American. And so how did this happen? She felt like she had a real story on her hands, right? And she's a professor at Harvard, so Google probably answers the phone when she calls, right? So she actually observed this first on Reuters, but it was the Google ad network. And so she called, and what did they say? They basically said, as far as I can tell, they said, we had nothing to do with it. There is no way that you would write an algorithm that would do this, right? I mean, it's awful. We don't want to suggest that people with black-sounding names have criminal records. That's nothing that we would ever do. We have no idea what's going on. So they said nothing to do with us. The interesting thing is that I think they're probably right. I mean, we don't know for sure. Professor Sweeney doesn't have the algorithm. I don't have it. Google isn't sharing it. We don't know exactly what happened. But one hypothesis for how this happened is that the Google AdWords platform actually allows you to put text for many different kinds of ads. And the idea is that you might want to try different wordings to see if one wording works better than another wording. So if you're an advertiser, you might put in a couple of versions of the same ad. And one would say blank arrested, and one would say find out the most recent address of blank, right? So you would put in more than one version of the same ad. And then they thought, you know what, let's give those advertisers a break, because it will be such a pain for them to look through the analytics for every version of their ad. We'll just write an algorithm that'll do that. And the algorithm will say, if it turns out that with certain queries, certain ads perform better, then just show those ads for those queries, right? So that's an algorithm that they could have written. And so who then, back to my question, is responsible? Who's responsible for this behavior where Google produces ads that suggest people with black names have criminal records? Well, it looks like it's the searchers, in part, because they're clicking on those ads with comma arrested more often when the search query is an African American name, right? But it's also, of course, the people who wrote this algorithm. They didn't seem to have thought through what would actually happen. So the algorithm kind of learned an undesirable behavior, which was immediately discontinued, by the way, by Google. So you will no longer see any of these ads because they don't want any behavior like this at all. But it seems to have been learned from the users. And so the point of this section of the talk is to emphasize that we're now in an interesting area with algorithms and media information. It's not just that we're seeing co-production, because if you're in science and technology studies, you always see co-production. So I would be saying nothing if I said this was co-production. It's that people and machines co-produce relevance. And that's important because in media and communication, we've had excitement for a while about computing and digital media, but we've really focused on other stuff. So we focused on stuff like, what about participatory culture? So that was about people producing content. So here, I'm not saying that. I'm not going to care about the content. That could be really great talk, but it's not this talk. What I'm saying is that people and machines are co-producing relevance or importance, and that they're doing so in a way that's really unprecedented, and we haven't worked out the implications of that yet. We're trained to the algorithm. It is trained to us. Just to give you a couple of examples of implications of the co-production of relevance that are interesting, and the co-production, I'll dive a little bit into one empirical study that I did, led by Madahari Islami, a doctoral student. This study reverse engineered the Facebook algorithm, sort of. It basically managed to produce, using the Facebook API, 2 columns. One column would be everything that could possibly appear in your news feed in reverse chronological order. I know you can't read it. I don't want you to read it. Just look at the 2 columns. The other column would produce the actual news feed, and then we changed the color, so the two columns, so that things that were not in your news feed from Facebook, but could have been in your news feed, were highlighted. So here we have a lovely story about self-driving Tesla by Keith Hampton, and if I were using our system, I would look at that and say, I really like Keith, and I like the self-driving Tesla. It's kind of funny that that wasn't in my news feed. I wonder why it wasn't. So our research design, which was a laboratory study where we brought 40 people into a lab, and we had them look at this, and we asked them questions about it. I'm not going to go into the details. I'm trying for a big overview talk, but just a couple of interesting findings. I mean, we had to ask people in part because we don't work at Facebook. Right? So I'm not doing a study where I tell you how Facebook works because I don't know. It's a secret. It's a trade secret. They're not going to tell us. We also wanted to ask people because how people think about this is really important, because if the algorithm's trained to you and you're trained to the algorithm and you think the algorithm does something, your model of what it's going to do is going to change how you act, right? So if you think, so there's some interesting folk theories about Facebook that you may have heard. One is that you should always like your post right away because it, quote, gets it started, right? No evidence that that's the case. But anyway, it's something that people do, right? You should always comment on your own post, right? So it changes your behavior, how you think the algorithm works. So with this example, we brought people in and we showed them pictures of things that Facebook filtered out, and we, in a more elaborate and rigorous scientific way, said, what do you think's going on here, guys? This is, what is that? One of the interesting things we found is that most people weren't aware that Facebook hid anything. In fact, 62% of people weren't aware that Facebook was reordering their feed, which was really surprising to us. So we kind of messed up the study pretty badly because we were trying to do a study of what they thought about algorithmic filtering, but they didn't think about it at all. They didn't know it happened. So that was, actually, they were really mad. Actually, they were really pissed when the ones that didn't know about it. When we told them, they were like, "What?" It's kind of intense because have you seen the movie The Matrix? It's kind of waking up in the Matrix in a way. I mean, you have what you think as your reality of like what they choose to show you, right? So, yeah, no, and this was deeply felt. So. But there's some interesting, so this was unexpected and interesting, but there were also, when they did figure out that Facebook filtered, and we went on to ask them why they thought Facebook would filter things, and we did end up getting some interesting answers. One of the answers that we got, one of the things that we got was really interesting, which we're calling algorithm attribution error, and it's summarized by this quote, "I always assumed that I wasn't really that close to her." And so it's that we know the algorithm combines things that people do, remember 150 to 1,000 factors, and things that Facebook does, but we're not able to disentangle these. And in fact, the people we spoke to always came down for the people. So whenever anything happened on Facebook, they would think about the people. So I posted something, it didn't get a lot of likes, it was about politics. It's because no one wants to see that. My friends hate politics. I'll never post anything about that again, right? So their explanations were not, maybe no one in my friend network saw that because it was filtered out because Facebook doesn't show everyone everything. So they didn't consider that. Usually they would think immediately of people. So when they didn't see someone on their feed, like for example, they had a conversation at Thanksgiving with a dear relative, and the relative said, "Oh, I put that on Facebook." And then they said, "Oh, I didn't see that on Facebook." They would think, she blocked me. It was that argument that we had, and so she hates me now. And so it would always be this idea about it was about the people. So I mean, I think this is profound in kind of a weird and poignant way, right? I mean, it's like over in Menlo Park, those people turn a dial on the big algorithm machine, and a big section of the world's population feels more unloved, right? I mean, it's interesting. We also found some other things. One of the things that I like about this study is we found that people had these really negative reactions to discovering that certain people they knew were systematically filtered out, because we had some summaries with bar graphs. And so they would find that certain people they knew were filtered out, like in this case, my brother, and they would be really mad. They'd see like, well, I can't filter out my brother because he's my brother. Then we showed them what the brother had posted and that it was filtered out, and what he'd posted that was filtered out. And they would say, oh yeah, that is really boring. Like, that is really boring. I can see why they filter that out as really boring. But ultimately, they were still mad because their feeling was that because he's my brother, he has this claim on me. He can make me consume his boring news. And it's my job as a family member to consume his boring updates. Right? And so they were mad about Facebook. So again, we see the optimization. So Facebook optimizing for something. Maybe it's likes, maybe it's engagement, comments. But it's got the wrong thing, right? It's got the wrong thing because, in fact, we need to see all of his boring updates and we need to like them so we can say that we're seeing them because that's what being in a family is. It's being bored a lot. This talk has gotten too personal. All right. The second big idea I want to talk about is algorithmic determinism. And I went in a little bit more detail in the first. So the second and third big ideas are shorter. So algorithmic determinism, and I'll tell you what I mean by that. Again, working through some examples. So the first example I have for you are these house numbers in the Netherlands. The Netherlands, I don't know if anyone's been over there, but they often have house numbers with a letter after them, an A, and that will usually mean that you're in a city. Number one, you're in a city. Number two, you're in the basement. It's usually the basement flat, I think. I could be wrong. If there's anyone from the Netherlands, feel free to correct me, but this is my understanding. I have been to the Netherlands. So anyway, an investigative reporting group in the Netherlands did an investigation of auto insurance rates. And they found that auto insurance rates in the Netherlands varied by hundreds of dollars in their 6-month or biannual fee based on whether there was a letter after your address or not. So in fact, the people who had an A after their address were paying hundreds of dollars more for auto insurance. And this was, I think it was a pretty good story. I mean, the people were outraged and they called for action and they demanded from the insurance agencies to know why it would possibly cost hundreds of dollars more for auto insurance. I mean, there isn't really a logical connection, right? Like, you live in a basement. Would that make you a worse driver, or do worse drivers live in basements? Or like, how does that work, right? I mean, is it about money? Are the basement ones cheaper? But there isn't really a correlation between money and driving ability, I don't think. And so it's a puzzler, right? So they asked the insurance agencies why exactly you would pay more. And their answer is so interesting, right? Because their answer is, that's not how actuarial science works. The way that actuarial science works is that we put a whole bunch of factors in a big bin, we try to assess risk, and we never reason about cause. We don't reason about cause and effect. It's not our job. What we're trying to do is just be sure that you don't have too many defaults in the pool. Or in other words, to optimize for something. We're just putting a bunch of information in the pool, using some statistics to figure out what produces the best result that makes sure our insurance company remains solvent and profitable. So that's what they said. So this should sound familiar because really what we have here is actuarial logic for understanding the world, but that's now become media logic. So media logic are now actuarial logic, really something that we haven't seen on this scale ever before because they have the same character of putting these things into a bin and then optimizing for something and not caring about the relationship. There's a great art piece that deals with this particular instance, this particular topic, by a Korean art collective called Shinsunbak Kim Young-hun. And I'm sorry for the pronunciation. It's pretty bad, I'm sure. But basically this art piece invites the viewer to walk into a gallery where there are these big canvases filled with a lot of little portrait pictures like this one. And there's one canvas on one side and one canvas on the other side. And on the first canvas, you see the people. So there's people's pictures. They're actually Creative Commons licensed headshots taken from Flickr. So if you have a Flickr account, maybe you're in this art piece. I don't know. And if you read the curation card, it says that these people have all been subject to a cat, or in other words, a feline face detection algorithm called KittyDar, and they've all been identified as cats. So everyone here has been identified as a cat by the KittyDar face detection algorithm. And then on the other side, they actually have a wall of cats. And the card says the cats on this wall have been identified as people using the OpenCV face detection algorithm, right? And so I really love this art piece, and I think the experience it gives you is the experience of thinking about algorithms. Because what do? You go there and you look and you think like, well, I don't know, like, it looks human-ish, like maybe, and you try to figure out like, what is it about, what is human about this? Is it the jaw? And you're trying to add the reasoning, right? I mean, maybe you go back to this one and you're like, oh, maybe it's like, you know, is it some collection of features, or is that guy, is it his hairline, or is it like, what is it that made him a cat? So I went further. I could not handle this art piece. I wanted more. And so I looked up the Kitty-Dar cat face detection algorithm, and I read the original research in computer science about cat face detection. This is some of the research. It involves detection of the characteristic ear crown. That's the state of the art in cat face detection. And you know, I also looked into OpenCV and I read how OpenCV detects faces. But really, at the end, even after I read the algorithm, what did I have? Because all I read was a set of mathematical and computational steps, and I understood them, but it never led me back to a place where I can look at these pictures and say why one of these is a human or not, or a cat or not. And the reason it didn't is because it would depend on how I trained the algorithm. Again, I didn't mention this in my previous explanations, but typically, with particular classes of curation algorithms, machine learning algorithms, you will train the algorithm by dumping in a huge amount of data, and then that data will produce the model that you're going to use to optimize for the particular output. And so, in fact, without knowing their data, I can't really get anywhere to answer the question of why these are humans. And even if I had the data, I'm still not sure that I could, right? Because, I mean, it's going to be a really elaborate model. Even though that OpenCV isn't that complicated, it's still going to be fairly elaborate, right? So think of this way of reasoning about algorithms as the way that we reason about all algorithms, actually. Because if you went to Google, let's go there today, let's go to Mountain View, and then you barged in there, you know, they have a whole division, relevance engineering it's called, which is kind of a funny, kind of Orwellian, or relevance engineering. You go see the director of relevance, which they have. You go see the director of relevance and you're like, why did I get this search result? You're the director of relevance, right? I mean, what are they going to say? 150 engineers at Google touch the algorithm. They change the algorithm 7 times a day. It's an elaborate socio-technical artifact, right? No single person is going to be able to reason, even if they had all the code, to a particular case, right? I mean, and if they did, it's a guess. So the interesting thing, earlier I talked about folk theories of the Facebook newsfeed. I mean, the professional theories of these algorithms may not be that much better, because these are very complicated systems, right? So it may be, this point made most effectively by Nick Seaver, it may be that the engineers on this are grappling just as much as we are with metaphors and approximations. They're trying to help us. Google has some public relations where they describe their search algorithm as a robotic nose that smells web pages to determine if they're good or not. So there's the algorithm. It smells the web pages. That one smells good, that one smells bad. My point for today, though, is the algorithm is now a way we reason about the world, and it's really intellectually significant. If you're into philosophy about reasoning about the world, particularly about reasoning about cause, taking this from a philosopher named Hacking, one way that you reason about cause that's now pretty out of fashion is causal determinism. And that way of reasoning about cause is, here's a cause and there's an effect. Things have causes and effects. And so actually, the bummer about causal determinism is that it's sometimes called an iron box because you have no free will. Because at some point in the past, there was a cause. It led to a bunch of effects and causes and effects and causes and effects and causes. And then now I'm walking around making jokes about cat pictures. And that's all just determined long ago because cause and effects are in these chains. We had a big move intellectually when we abandoned causal determinism and we started with probability. The way we reason about cause and effect with probabilistic determinism is we say, well, ultimately the universe is random. It's not an iron box, it's random. Ultimately the universe is random, and we know that certain things we can do might make some outcome more or less likely. So we reason in this probability way, more or less likely. But now let's think about how we reason with the algorithm. I mean, the way we reason with the algorithm is sort of like we have an optimization, and our attempt to produce the highest value on the optimization that we use is then what we'll do, and we no longer care about why. So it's like the abandonment of cause and effect, and it's not just abandoned because we don't care anymore, it's abandoned because also the systems have become too complex. So there's not a really great way to extract the cause and effect from, say, a machine learning algorithm with a big data set. It's just not clear you're ever going to be able to do it. And so as a consequence, we kind of have to say, like, well, things happen for some reason, but we don't care. And so it's abandoning sort of an explanation. So why, and again, it's actuarial thinking. Why do you pay hundreds of dollars more if you live in a flat that ends in A? That's not how the world works. That's the optimization, right? So why is it that this is on my newsfeed and not that? Well, don't ask, because it's just how the world works. Really profound in terms of, oops, I said that already. Really profound in terms of accountability, right? Really profound. So for example, this is a novel I read last year. I don't like it, so I'm sorry if the novelist is on the feed right now. Don't like it, don't recommend it. But it's sci-fi, it's set in the future. I'm not going to spoil it in case you want to read a bad novel. It's on the back cover. The way this novel goes is that in the far future, hundreds of years in the future, I think, if I remember, they built a computer, and they call it the algorithm, and it's going to optimize human happiness. And so they're going to feed all the data of the world into the computer, and then the computer is going to decide, see if then, what to do. And so then everyone's really excited about the prospect of maximizing human happiness. But, and again, I'm not giving anything away, the computer says we have to refight World War I. And everyone is extremely surprised. Because this is hundreds of years in the future. That's not what they were expecting the computer to say. It would be a little like if I said to you, what do you want me to pick up at the store? And you said, let's refight World War I. Like, it doesn't make any sense, right? Why would you refight World War I right now? But I love the characters, right? Because the characters are like, well, it's got to know something. You know? It's a lot of data in there. It's really advanced, you know? Maybe we should refight World War I. And it wanted to reenact World War I. Like, it wanted everyone to start digging trenches, right? And get those pie-shaped hats and everything, right? And so people were like, well, it doesn't seem like a good idea. But, I mean, maybe if we do it, we will get to the human happiness at the end, right? And so that's algorithmic determinism. My last big idea for thinking about algorithms is corrupt personalization. And my example to help think through this idea is the Bic crystal for her. I don't know if anyone remembers the Bic crystal for her, but it is a misguided attempt by the pen manufacturer Bic to produce a ballpoint pen just for women. You see here that one thing that happened as the result of this is that the Amazon.com reviews for the Bic crystal for her became extremely funny. Because a big gang of feminists decided to post reviews. You see there's, thousands of reviews on this, 1,053 reviews. And so it's a very, very funny review section. They've withdrawn the product, but it's still on Amazon if you want to check it out. It's pretty funny. So I posted this to my Facebook newsfeed because I thought it was funny. And I try to get people to like me by making jokes. And so I posted it. And then one of the things that happened as a result is that, so I didn't actually save my status update, but let's just imagine that it's something like this. I posted it, and then, it got some likes and whatever. And then a while back, I came back, and I looked over a friend's shoulder while they were using Facebook, and my status update about the Bic crystal for her was at the top of their feed, and it had been like a week or something, and I thought that things cycled through a little faster than that, so I was a little surprised. And then later, I saw it on another friend, and it was at the top again, and this is like 14 days later, and nothing really stays on Facebook that long, so I was pretty confused by it. Like, why is this always at the top? I mean, the reason that it was always at the top is at the time, Facebook was experimenting with a particular kind of revenue generation strategy where they would allow advertisers to purchase your words if you wrote about corporate products, and then they would boost those to the top of your friend's newsfeed. But they wouldn't do that on your newsfeed because they, I suspect, didn't want you knowing about this feature because they suspected, as it ultimately was, that it would be extremely unpopular with their users, right? So the only way you could discover this feature was by looking over a friend's shoulder. They did label it as a sponsored post, but it's very light gray, and I feel like I'm an expert on this topic, but I didn't initially see that it was a sponsored post. It's very hard to see. They since withdrew this way of raising revenue. They no longer do it, called sponsored stories, because word did get out. And people really were pissed off. They didn't like the idea. It also didn't work that well because people would sometimes make fun of products, and then the algorithm wouldn't be smart enough to figure out that was what's happening. So it would be like a vegetarian would say, like, the McLobster is so disgusting, and then it would be like, you know, so-and-so likes the McLobster, and it's to show that status update, right? And the McDonald's ad, why don't you try some McLobster? So the point of this example is that we often think of these systems as though they're doing something for us, and that's the logic of personalization. The companies involved prefer personalization to filtering because it sounds great, personalization. Filtering sounds like you leave something out, but personalization sounds like it's just for you. My point to you is that as scholars and researchers and students in media and communication, we know that the media industrial system has a variety of agendas that aren't providing the best thing for you, right? And so we need to be able to watch for cases where the agenda of the algorithm and our agenda differ, and they're going to differ. It's true that if Google search results always produced terrible results, we would not use Google. So I'm not saying that there isn't some way in which we need to serve the user with our algorithms, but there may be a variety of other things that our algorithms are doing that are absolutely not something that we're after. I'll give you a more sort of less commercial example. This was from the Wall Street Journal investigative reporting team, which is a fabulous team. Julia Angwin did some amazing work before leaving for ProPublica. And this story, broken by the Wall Street Journal, was about how people find out political positions way back in the previous presidential election. You remember we had one a while ago that wasn't this one. And in that presidential election, the investigative reporting team found that if you searched Google for issues that were important to the presidential race, the search results that you would get back would make it very easy to find President Obama's positions, but fairly difficult to find his challenger. Does anyone even remember his challenger? Yeah, that's right, Romney. So Google actually was experimenting at the time, sort of like, why am I seeing this, with putting messages on its personalized content. And so this was one of the messages it put on its personalized content. You recently searched for Obama. So this was a struggle. People tried to figure out why exactly it would be easier to find Obama positions and not Romney positions. I mean, people were thinking, well, he's a sitting president, so maybe there's just more stuff on the web about him. But in fact, it seemed even harder to find Romney than you would have thought by their investigation. And what they ended up concluding was that Google had not foreseen the idea that presidential elections produce topics that change rapidly. And so they had designed the algorithm with a certain periodicity of how topics change. What they had done is they had trained their machine learning data on a particular data set, and they hadn't updated it. And so, in fact, Romney wasn't in it. And so for certain topics, he wasn't in it because he wasn't running for president when they did it. And they didn't realize that this was important. And they did after the Wall Street Journal pointed it out. I mean, they didn't. I don't think they were on the record as saying, like, oops. But, I mean, obviously it wasn't their intent to not realize that presidential elections happen or that topics change. But we have here an assumption built into the algorithm about something that seems very minor or at least abstract, like the periodicity of how often topics change. And they had certain ideas about how often people think about changing Medicare or something like that. And they thought their main client base was really like, I don't know, high school students writing reports maybe in the 8th grade or something. And so they designed it one way, and then it turned out the election was going on, and it was still using the older way that they designed. So all this to say that a central problem of mediated experience is now that algorithms pursue agendas that may be opaque and harmful to us, and they don't match our own agendas. They also are going to try and serve us, right? Because they don't want us to go away. I've been calling this corrupt personalization, which is a sort of fun allusion to Baker, if anyone remembers Baker, but also very indebted to the work of Strippis and Gillespie. So, okay. those are my three big ideas. I'll conclude by asking what we're supposed to do if I'm right about these three big ideas. I just have a few remarks, then I'll open it up for questions. So one thing that people have said about the situation I'm describing to you is that we should have algorithmic transparency. It's creepy that all these computers are doing things we don't understand, so we should get the companies to show us the algorithms. I hope that I've convinced you in this talk that that won't work. It won't work because the companies themselves don't know what the algorithms do necessarily. The algorithms are very complicated. It's not clear what giving you all the lines of code would accomplish. In some cases it might help, but not generally. I gave a version of this talk at another institution about 3 months ago, and someone came up to me afterwards and complimented me, and they said, "Your findings are very interesting." And I got all ready to smile and be happy. And then they said, "In Europe." I was very confused because I thought, well, the findings are the findings, right? Like, they're interesting here in Europe. What are you talking about? But then I realized what they were saying was that, well, it's interesting that we're getting screwed so bad, but there's no political will in the United States to actually do anything about any of these problems, and these corporations get to set the agenda, so maybe over in Europe they would care. They would listen to your sad violin. But here, you know, not much prospect. That could be the case. I'm not sure. We have had calls for algorithmic regulation. Most recently, Ashkan Soltani, who was at the FTC, they opened a new unit at the FTC that was popularly called the algorithm sheriff. That's what people were talking about it as. But then he spectacularly, or I guess notably, failed his background check when he was trying to point it to the White House and got rid of him. So I'm not sure of the prospects. Algorithmic. Okay. Another thing that people in media like to say is literacy, and it sounds great. Who's against it? Literacy sounds good. So another thing we could do is we could have lectures like this one where I scare everybody about algorithms, and we could start doing that to our children. That's what they do to children now with social media. My daughter in middle school has these lectures she has to attend about how terrifying social media is and how they're going to ruin her life if she uses it. So we could go that route. What a depressing way to go. It basically is like abandoning the war. It's giving up. It's saying, well, these systems that we built don't do what we want, and there are a lot of negative side effects, but I guess we'll just have to scare our children forever. You know, I mean, this is why I'm not so happy about this. Yes, media professionals need to know about algorithms. Yes, experts, researchers need to know about algorithms, but the general public, teaching them that computers are scary and doing scary things with their data, I wish that's not it. I don't think that's what we should be doing. My last suggestion is the one I'm most excited about, algorithmic auditing, and I'll pick up on it in the Q&A if you're interested. And that's basically taking the social science research method of the audit study, originally proposed in economics to study housing discrimination, and apply it to algorithms. Because discrimination in housing is a black box, just like algorithms are a black box. You can't saw open the racist landlord's brain and determine how the neurons produced him not showing the apartment, right? So it's a black box. But an audit study tries to test for discrimination by systematically varying the inputs and then looking at the outputs. That was a very, very truncated description of it, but anyway, I'll say more about it if you like during the Q&A. I'll close with a reflection here. Ted Nelson quote, "The good news about computers is that they do what you tell them to do. The bad news is that they do what you tell them to do." So to recap, in this talk, I have argued that curation algorithms are pervasive in media and information. I've argued that we are only at the beginning of understanding the implications of these algorithms, and there are potentially many negative implications as well as positive implications. I gave you 3 ways to think about algorithms that I think are useful in this scenario. The first one I called the co-production of relevance. I said that co-production is a new way of thinking about importance or relevance. The second one, I said algorithmic determinism, and I said that the algorithm is now a way of thinking about the world. So it's not just a way of thinking about itself, it's a way of thinking about anything, about cause and effect. And then the third one, I said corrupt personalization. I said that the algorithm, the fun thing about these algorithms is that they often appear to be doing one thing, but they're actually doing another thing. I'll close there, and I'll take your questions. Thank you very much.